Planetarium. Thank you so much for joining us this evening for this Eddy lecture series. Before we get to the important topic of the science of Vermont's climate, a few points of order. Today's presentation is an Eddy lecture. It's a series intended to open our eyes to the world around us, and I certainly expect this discussion tonight to do that. The series is supported by the Eddy Lecture Committee, and we are indebted to their service in making this happen. So for tonight, I am truly sorry to report that Steve Maleski is not able to join us. He sends his very sincere regrets, and I know that will come as a disappointment to many of our viewers, and we're really sad to not have him here tonight. Steve, however, would scold me if I did not mention that the Fairbanks Museum has been making weather observations at its site in St. Johnsbury since 1895, and we maintain the second longest continuous weather record in the United States. So that weather record, or a summary or summaries of it, can be accessed at the Fairbanks Museum's website. So if you go to that website, we've done all sorts of analysis of that data, so you can take a look at it there. So for the discussion tonight, we welcome your comments. Those can be put in comments and questions. Those can be put into the question and answer function on your screen. So as you fill those in, they'll be seen by our hosts and participants, and they'll be answered in turn. So to host this Eddy lecture, we are very pleased to have Vermont Public Radio's Jane Lindholm. Jane is the host, executive producer, and creator of the But Why podcast, and the very recently, until this last March, she was the host of the award-winning Vermont Public Radio program, Vermont Edition, which I'm sure almost all of our guests have heard. So from here, I'm going to turn it over to Jane and our panelists. Thank you.
Thank you, Adam. I really appreciate the introduction, both to me and to this event tonight. And I'm so honored to be moderating this conversation and so glad to be asked, because I'm really eager to learn more from the wonderful panel that you have assembled for this conversation. And I do want to remind you, our audience out there tonight, that although we can't see you, we really do feel your presence, and we want you to be part of this conversation. After all, many, if not all of us watching and participating tonight share this Vermont landscape and community, and regardless, we are all part of a larger global community. And we want it to thrive, not just for ourselves, but for our children and grandchildren. I have two children, ages 4 and 7, and I think a lot and worry about what things are going to be like for them when they're my age, 35 years from now. What kind of world our global children are going to be facing. And especially as we think more clearly and forcefully about social justice and equity issues, how climate change plays into the possibilities for people depending on where they live, how much mobility they have, and how much money they have. So please do contribute your questions in that chat function, that Q&A function, as we move forward with this discussion, and I will try to weave them throughout our conversation over the next hour or so. I am, as I said, really thrilled with the panel the Fairbanks has assembled, and I, too, am so disappointed that Steve Maleski won't be able to join us. His has been such an important voice in Vermont meteorology, in the Northeast Kingdom, and in the discussion about climate change for decades, really. But we have 3 other wonderful and insightful speakers this evening, so let me introduce them to you. And if they would like to turn on their videos now, you can see their faces as well. Lesley-Ann Dupigny-Giroux is the Vermont State Climatologist. She's also a professor of climatology in the Department of Geography at the University of Vermont. She does a lot of different kinds of work with a special focus on flooding and drought, which are connected in interesting ways, and we may be able to get into that some tonight. And in her state job, she gets to spend a lot of time talking with schools, community groups, legislators, and state leaders. Lesley-Ann, it's a pleasure to talk with you again. Thank you for being here tonight.
Thanks, Jane. It's always wonderful to be in your company.
Ryan Rebozo is the new Director of Conservation Science at the Vermont Center for Ecostudies. And in his own research and work, he looks at disturbance ecology, plant-insect interactions, mycology, and rare plant demography. And Ryan, I can't wait to hear more about that. It's such a pleasure to meet you. Welcome.
Thanks, Jane. Thanks for the introduction, and happy to be on the panel.
And also joining us tonight is Janel Hanrahan, Associate Professor and Chair of Atmospheric Sciences at Northern Vermont University, Linden. Janel has studied the effects of climate change on the Great Lakes. She's done work in Edmonton, Alberta, looking at how that city should think about extreme rain due to climate change in redesigning its hydraulic infrastructure. And she works with students to improve climate change literacy among the general public, which is something that I think all of us could use a little help with as well. Janel, it's such a pleasure to meet you. Thank you for being here tonight.
It's great to be here. Thank you.
And so, as you can see, audience, they have some special skills in translating really complex scientific studies and models and data to give us information that we can understand and then perhaps use to take action. So let's dive right into the conversation. And, I'd love to start maybe by just exploring what each of you is already seeing in the Vermont climate and landscape that you can attribute to climate change. Lesley-Ann, could we start with you on that?
Thanks, Jane. And I think for me, because of my personal research interests, it usually comes down to precipitation extremes, so either floods or droughts. And I think Janelle could probably also speak to this because of her interest in heavy rainfall. And when we think about the increases in heavy rainfall that we've been seeing in the last few decades, the sector that is one that I always think about most is infrastructure, and particularly transportation infrastructure, because that is a sector that usually bears the brunt of whenever we have things like culverts blowing, or like we saw in the case of Hurricane Irene, road washouts, or communities being isolated because of entire failures in parts of the transportation infrastructure. And so I think it's non-trivial because of our physical geography, because of our history, and because of where a lot of our roads, state roads and otherwise, are located in valleys with respect to where the rivers are. And so for us, it's one of those particular challenges that it's always on your mind, because you drive through the state and you see some of those touch points where a lot of the damage could really occur in the blink of an eye, literally.
So when you think about it, you sort of see those extreme events and how they intersect with human development and those touch points. Are you seeing the effects of climate change on a more daily basis as well, or are we not quite there yet?
So I think for me, I'm more sort of like thinking longer term and thinking about my colleagues who work at, for example, VTrans, and the really tough choices and decisions that they have to make in terms of bringing climate change into their planning. So how do we size culverts? So how do we plan for different types of materials on roads and things like that? So it's sort of like, if we know that some of these things are coming down the pike, how do we plan for them?
Janelle Hanrahan, what about you? What are you seeing in the Vermont climate and landscape that you think directly speaks to climate change or speaks to the future of Vermont's landscape with climate change?
Sure. So, like Lesley-Ann, I think my perspective is more taking a look at the data and the long-term trends. I've been here for about 9 years, and so I would say that I personally have not experienced huge shifts that I've heard some lifelong Vermonters talking about. But one thing I will say is that as a climate scientist, when I was looking for a job back 9-10 years ago, that was one thing that was absolutely on my mind, is taking a look at climate trends in various parts of the country and climate change projections. And when I got here and I started looking for a house, I knew that I wanted to get a house that was not in a valley. I wanted to get something that was higher up because I know precipitation is going to be more extreme in this area. And so I guess my perspective is really more hearing stories from lifelong Vermonters, but then also being able to look at the trends that we've been seeing over the last several decades, which of course are extended into projections going forward. So not only more precipitation throughout the year, but also more extreme precipitation. So when it rains, it really rains. But at the same time, intertwined within there, you can get longer durations where we don't have any rain. So you can have drought and extreme precipitation both increasing in the same location. And then, of course, we're seeing changes in temperature. We're just temperatures kind of going up year round. We've had some really nice snowfall in recent years, but then you have those melts in between, or you have the kind of that crusting on top, and that can have some pretty big impacts as well.
You mentioned when you thought about where to live that one of the considerations for you was what's the landscape around it and what is the possibility of flood or other things that might be coming down the pike. And, we saw that in Tropical Storm Irene. we certainly saw where human development had been in floodplains or next to rivers and in valleys, as Lesley-Ann was talking about. But we also saw the inequity in that situation. How many places with lots of trailers, for example, were situated in floodplains, and how many people had such little recourse when their homes were flooded or their land, the land that they had been living on, was flooded. So how do you think about that, Janel? Not just, for your personal choices, but for that sense of inequity that is coming with climate change, when people who have fewer resources and less of an ability to choose where to live or to pay to live in some place that is less likely to flood are faced with those same questions and consequences?
Yeah, that's a really great question. I moved here actually the year after Irene, so I just saw some of the aftermath when I got here. And I think this question about equity is huge. I mean, as I said, when I purchased my house, I got a house that was higher up, right? It costs more money to purchase a house that's on a mountaintop or on a hilltop than it would be maybe to have a home that's in a lower valley that might flood. I guess I was just thinking about this today because actually a story that I heard on VPR today was talking about what Floridians are doing to adapt to climate change. Now it's a little different because it's talking about sea level rise, but I think this equity issue is definitely at play, where some people there are just saying their solution is to put their house on stilts. Well, I imagine that's a very expensive thing to do, and there's only certain people who can afford to adapt in that way. And so I think right now the thing that we really need to be grappling with is how can we stop climate change from getting as bad as it could potentially be, so that not so many people need to adapt and that these inequities don't continue to grow.
Lesley-Ann, did you want to weigh in?
I did. And just to piggyback on what Janel said, I think those are the very, very difficult and challenging questions that we're starting to ask, especially in light of all of the events that we've seen in the last 14 months or so, and the way that social justice and climate justice and everything that has to do with us as human beings, putting that equity lens to sort of look through that and ask, are we being as equitable and equal as we could be and should be? And so I'm also on the Vermont Climate Council, which is part of the Global Warming Solutions Act. And one of our subcommittees, their particular focus is to look at just transitions and the way in which making sure that all Vermonters are at the table, all Vermonters' voices are heard, so that, that question of, do we have all of the ways of knowing? Do we have all of the ways of sharing information? Do we have all those questions of access really posed, so that we can start to try and maybe answer them? I think it's a step in the right direction, but we haven't done it before, so there's going to be growing pains, and it's going to be really, really tough, because once you start having challenging conversations like that, then that's where the rubber really meets the road, right? So it's just one of those pieces, and I think it's good that we're starting it, but I know we have a lot of work to do.
And maybe we can touch back on that later in our conversation when we talk about things like policy changes and how to make sure that policy changes that push people to choices that involve, less carbon are not also regressive, don't affect people who, again, have fewer choices about what kind of car to buy or what kind of power to use. But Ryan Rebozo, let's bring you into the conversation. We were just talking with Janel Hanrahan, who moved here several years ago and was thinking about where to live. You have more recently moved to the state, and we've been hearing a lot in recent months about, I guess it's now being called climate migration, and I'm curious if the move to Vermont, aside from the wonderful job that you have that brought you here, if you were thinking about climate as an ecologist as you made the move here.
Sure. Yeah, it was certainly a combination of the job and the location. Definitely a general region that I had my eye on as one of the few places I would consider moving to for work. So that certainly played a piece of it. But like you said, as an ecologist, I'm kind of viewing this along the lens of biodiversity and species interactions. And what's interesting about that, and the kind of the frame of mind I have when I look at it, is trying to understand that we're looking at species constantly in competition. Those that are better competitors get to persist in a given area, and those that are least competitive get excluded. And what we're seeing is certainly species that are kind of at the edge of the range are already starting to do one of two things. They're either changing their phenology, so the timing of some of these life history traits, think breeding, think flowering time, or they're actually shifting their range to find more suitable habitats. So, when I say species at the edge of the range, some of the northern tree species that exist in Vermont, about 70% are already starting to have their range shift northward. We're seeing that in some breeding birds as well. So it's already, already people with long-term data sets are already starting to pick up on some of these changes that we can attribute to a rapidly changing climate.
I've heard that may also be true for moose, which are, facing some pretty startling winter tick issues, but also are moving their range north and may even be extirpated from Vermont within the next couple of decades. Sure,
that's a great example of wintertime lows being such an important limiting factor in what persists in this area. Wintertime low temperatures, so our minimum winter temperatures, and also the persistence of snow through the winter, right? When is melt out? How deep is the snowpack? These are some of the real limiting factors into what species can persist here. And when we see that start to change, some of the balance in terms of the natural diversity we'd expect in the area starts to shift as well.
Are we seeing those factors go into play as well for our maple trees, which are also under threat from climate change, or is it different kinds of factors from climate change?
Sure, that's part of it. I mean, if we're thinking of sugar maples, one thing that's really important to sugar maples is that transition from winter to spring, right? We know that's kind of sugaring season. We know there's a lot of moisture in the ground at that time. That's important for sugar maples. But what I think we're expecting to see is another native maple or red maple becoming even more common and more widely distributed than it already is, right? So a little bit of a forest composition change in that sense.
It's interesting as we look at things that we can notice in our own backyards, although, unfortunately, many of us don't have moose in our own backyards. But, some of us, like for me, I used to just hustle people into the car and go to Island Pond because I knew I could reliably show an out-of-towner a moose in Island Pond. And now I can't. So, we don't make the trek from Madison County as much. But we as Vermonters and as people like to be able to see things in our own lives and then sort of relate it to what's happening more broadly. And, we got a question from Dawn in St. Johnsbury, who wonders about a lack of birds in the area and wonders if that is related to climate change. And, I'd love to talk a little bit about how we take stock and how we contextualize what are natural fluctuations in things like bird populations in our backyard or weather versus climate and long-term trends and climate change. And Lesley-Ann, I know you think about those long-term trends and climate change and perhaps slightly less about birds in Don's neighborhood, but how do we contextualize what we are seeing and experiencing and relate it to what we are reading about climate change?
So I may not be an expert in birds, but I was sort of like shaking my head along with when Brian was saying his experience and his observations, because I think at the core of it all is thinking of it as a system. And if one part of the system changes, the other part also changes, kind of like maybe a little bit of a domino effect. And so it doesn't matter what type of scientist you are. If you're thinking of it from a system science perspective, you're going to try to look at those individual pieces. And for me as a climatologist, having that long-term record, that long-term perspective allows me to see when those shifts occur, the changes in the patterns, allows you to get a feel for exactly where those touch points are in terms of things moving in and out. And it's great to be on a panel like this because Janel is using similar data, but looking at it slightly differently and using slightly different models, but the underlying core physics of the process is still the same. And we're just maybe looking for different patterns or looking at it from a different perspective in terms of who is being affected. So that's kind of like the fascinating part in all of that. And how do you use the data to translate it into models to then make sense from it of a complete system? And that's where, some of the things that Ryan's talking about also fit in, because the weather then drives where the species are. And if that changes on a long term, which is what climate is, then those are going to show up in changes in species composition and dynamics. So
and
Janel,
again, I so wish Yeah, I so wish Steve was here, because Steve has been on that trajectory in his professional life.
Absolutely.
Think about that change between what is weather and what is climate, and how do you connect the two, and how do you say, well, we can't pinpoint this particular weather event as climate change, but when you look at the trend over time, we see something changing. And so, Janel, Hanrahan, how do you think about that? How do you think about that in your own research, but also in that work you do, helping new and emerging scientists do that kind of scientific literacy for the rest of us?
So there's a lot packed into that question. So I teach a 2-semester course here that all of our atmospheric sciences and climate change science students take. It's called Climatology and Statistics. And it's a course that our students take usually during their second year in the program. And those two are brought together intentionally, because you can't really teach climatology without including statistics. Of course, you could probably teach statistics without climatology, but who would want to do that? But we really need to bring those things together, because that's really what climatology is. It's the long-term statistics of weather. And I know that people oftentimes cringe when they think the word statistics, but it really just means averages. It means variability. It means trends. So, for example, as we're moving into the summer months here, finally here in Vermont, we know that the sun is getting higher in the sky, that the days are longer, and those things together will create more energy coming into our climate here regionally than what's leaving. And therefore, we know that average temperatures are going to continue to increase throughout the summer. And so we're really looking at the average. But when we're talking about climatology, or especially like a climate forecast, we're not going to say we know it's going to rain on this day, I don't know, July 4th or something like that. But we know kind of the average, what we would expect to happen. I think another concrete example is that we have the solar eclipse coming up here in just a couple of years, and it's going to be during spring, and it also happens to coincide with the 50th anniversary of our department. And so we are so excited to bring a bunch of our alumni back, 4 which, by the way, are at the Fairbanks Museum. And we're excited to bring them all back, those that aren't here, because our students oftentimes like to travel all over the country to catch solar eclipses. But at the same time, during the spring, it tends to be pretty cloudy. So we're a little nervous about it, right? So climatology tells us that we may not be able to see the solar eclipse, but we won't actually know until just a couple days before, based on weather forecasts, whether or not we're actually going to be able to see the solar eclipse. But they're tied together. It's really the same thing.
Maybe you should consider doing, like an NVU Linden extension to Hawaii for the solar eclipse. I think that sounds like a good plan.
I've already pitched it. It was a no-go.
I'd sign up for it. I just wanted to add one thing that it's interesting you brought up the averages, Janelle. So yesterday they released the new 30-year averages. We call them climate normals, and normals really means averages. So the 1991 to 2020 normals were released yesterday, and we're all excited about that, because now we have a new average period to look back and compare how the changes are actually being observed.
And anything that you want to share with us from those averages, those normals that were reported and released?
Not yet, because I haven't looked at them.
I can comment on it briefly, because I actually just showed it to my climate change dynamics students right before this. But what we know is that the last 30, and usually these climatologies are redefined, at least according to NOAA, by decades. It's arbitrary, but they want to have the entire decade. And so the reason why we have this new climatology is because we just finished the year 2020. So the new one is between 1991 and 2020, because by definition, the climatology is a 30-year average. So the previous climatology ended in 2010. And so now we're able to bring in that new decade. But what we did find is that when you compare the new climatology to the old climatology, that there's warming pretty much across the entire continental United States, and that precipitation, at least the annual average, because that's as far as I've looked at it so far, pretty much the entire eastern side of the United States is wetter now, and almost the entire western side, but especially the southwestern side, is now drier.
Want to remind those of you who are watching that you can participate tonight and go ahead and throw your question in the Q&A area of the question area, because we'd love to sprinkle those in throughout the conversation. And as you're hearing things, if you're hearing things and saying, "Wait a minute, what does that mean?" or "I have a question about that," go ahead and type your question into the Q&A. Alan B has added a couple, and Ryan, maybe you can tackle one of them. So Alan says, "Birds and moose are easy to notice missing. Are there important soil organisms and pollinators that we see similar migration and threat to?"
So Alan nailed it. This was something I would hope would come up, and I'm glad we're getting to it now. Yes. So part of the problem is, it's amazing how little we know about the biodiversity in our own state. I mean, he's absolutely right. Mammals, birds. We have pretty good records of these species. We can understand what's moving, what's declining. But even when it comes to insects, even before we get down into the organisms that are living within the soil or below ground, we really don't have a great understanding. One of the major programs at VCE is Vermont Atlas of Life, and trying to compile as much information we can about diversity. And even pretty important and charismatic groups of insects, say bees, that most people think of if they think pollination or insects, we're finding we still don't even have a great grasp on them. And when we do dig more into the long-term trends on these organisms, we're finding declines there too. And that stands to reason with soil. And soil is such a big part of this discussion. I mean, its ability to capture and store carbon, it's the amount of biodiversity it holds is impressive, and that biodiversity that exists in the soil is so closely tied to what we see above ground. So part of the challenge in understanding what changes to biodiversity is going to look like in the future is even just understanding what biodiversity we have around us now.
And that doesn't have to be just you and your colleagues, right? I mean, there are all kinds of calls for citizen science in Vermont. And sometimes, so I'll post insect pictures on Instagram, and Kent McFarland or somebody else in the conservation world in Vermont will say, "Put it on iNaturalist," or, "Send it to the Vermont Atlas." Do you really want that kind of citizen involvement and citizen science for something other than feel-good participation?
Absolutely. And then that's where I was going to go next with this. Is it's been incredible how much biodiversity data is coming in from community scientists. And that is really helping to round out the picture. You can only spend so many field hours if it's just restricted to the research community. So the fact that people have the ability to go out and cover the state, upload the information easier than ever on a phone, and even some of the new technology that has this AI technology that can help identify species is making this easier than ever, and is really already contributing in a significant way to our collection and curating of biodiversity data.
Does it also have an important effect, even if it is just that sort of feel-good piece of it, that people who do feel more connected to the natural landscape around them are they more likely to take conservation action or not?
Sure. I mean, there is that feel-good component to it is important. I mean, you have more people that are more connected and more aware of what's going on in their surroundings. They're contributing something that's useful. And a lot of the issues when it comes to conservation or protecting rare species and communities is, a large part of the population is maybe unaware. In the botanical community, we call it plant blindness, right? We know plants are around, but we don't really know what we're looking at. And it makes it hard to want to protect something like that. And the more people that are involved in this stuff might start, bucking the trend, and we get a little more interest in these less charismatic but still declining species.
Lesley-Ann Walter of East Haven says, "How is climate change affecting Vermont's snowfall? Is there a statewide trend towards snowier or less snow? And does the effect vary north to south by elevation? What's the trend in average snow depth?"
So I wanted to just respond to one thing that Ryan brought up before I start to answer that, and then I'm going to pass it to Janel, because one of her colleagues, Jay Schaefer, is one of the snow experts here in the state. Ryan was talking about citizen science, and I cannot stress how important that is in terms of some of the things that we do as scientists, because I would say 20, 30 years ago, we didn't have access to the ability to have input information sort of coming in from so many places, from so many people, all the time. It was usually like specific field days or field campaigns that were organized, like an Arbor Day or something like that. And now the ability to have these not just local, regional, but national archives and sites where people can upload the data, the pictures, the geotag, the geocached information that they have has sort of blown the way of looking at information and data out of the water, because it helps us sort of validate our models and actually see and observe things that we didn't or weren't able to before because we didn't have all of those observations coming in. So I really sort of thank Brian for bringing up that citizen science piece, because it's one thing that we can all do as individuals, use our phones or iPhones or whatever devices we have to actually collect those data and sort of put them in. So for the snow part, I'm actually going to send that to Janel.
So I like how Lesley-Ann passed it on to me, and actually on the other side of my wall here is
It's okay.
Jay Schaefer's office. So I'm not actually the cold season expert. But I can take a stab at that. So I think it's important to remember there's a difference between snowpack and snowfall. So it's generally thought, and this is in general agreement, I think, amongst the scientific community, that Vermont may potentially be in kind of this sweet spot in the upcoming decade or two. And that's simply because of the fact that a warmer climate can hold more water vapor within the atmosphere. And so as long as our temperature here is below freezing, at least part of the time, that precipitation will then fall as snow. And so those two things together will mean that we could potentially have more snowfall for maybe the short term. But then we think about snowpack, where you have snow that falls on the ground, and you're only going to be able to add to it if you have more snow that falls on top of it before it melts. So we do also know that we have more periods where in the middle of winter, you have this thaw that lasts maybe a day, maybe two, or even longer. So you tend to lose that snowpack. I don't know what the actual climatology is or the trends of existing snowpack in our area, but I do believe that the actual snowfall has been tending to increase.
And that's where that notion and understanding of climate variability also comes in, that sort of variation that you see from one year to the next. Because I would say about 10 years ago, the understanding was that because the climate was warming, everything would fall as rain. And now we're getting a better understanding of the nuances, that it's not just that sort of linear approach to it, but the fact that one year can vary from the other. And so you can get a lot of snow in one year and then little in the next year, like we've seen this last 14 months or so. But then at the same time, you can also get a lot of snow in one part of the season and rain in the other part of the season. And then to get back to Janelle's point of whether that snow actually accumulates on the ground, then sets up the next piece of what happens to it when it starts to melt. And do you get springtime flooding or not, because of the combination of how much fell, whether it stayed, and how quickly it went, and if it was a rain on snow event. So I think we're starting to learn a little bit more of those nuances of how some of these pieces, again, of the system fit together in how much falls, where it falls, whether it stays, and how it goes.
And if I may, Jane, I just want to add one more piece to that, because this is a really interesting application to all of this for me as a climate scientist. I was invited to present for New Hampshire Golf Course Superintendent Association last year. I guess it was before COVID. And so I had to do a whole bunch of research to find out how what I knew could be applied to what they care about. And as it turns out, what they care about is turf grass. They care about the health of their turf grass. I guess that's where most of their energy goes, is maintaining that and making sure it's healthy. And when I did some trend analyses for that particular region in New Hampshire, and what I found again was that you have more of these melting periods throughout the winter. And I had some fantastic conversations with some of these superintendents, how this is something they're very concerned about, because snowpack, a consistent snowpack, essentially protects that turf grass, which happens to be pretty sensitive to the cold. And as soon as you lose that snowpack and then you get something like freezing rain on top of it, it can kill just acres and acres of this turf grass, which of course can be very expensive. So I just thought that was, for me, very eye-opening in terms of thinking about, even though for a lot of us, this might seem like really subtle changes, it can have pretty substantial impacts.
When you think about something like people who are overseeing golf courses, which also require a lot of upkeep and maintenance, and in certain parts of the country a lot of water in places that don't always have a lot of water. People will point to golf courses as one visible example of something that's wrong with our country as we think about climate change. But it's interesting to me that you point that out, Janel, because, here's a group of people who are very closely aligned with what's happening with changes on the landscape, and perhaps in a surprising way. And it reminds me a little bit of, conversations around conservation and the hunting community and how involved in conservation the hunting community can be. So are there ways to pull in people who have vested financial interests and ones that sometimes seem like they're in direct conflict with what we want to do with the climate, but to pull these different kinds of people with different interests together to move in one direction to help mitigate climate change?
Yes. That's exactly what needs to be done. I don't know how often I present somewhere and I have people look up to me and say, well, what about the economy? What about this? What about this? And my response is always, I don't know. I'm a climate scientist. We need to, this is exactly why this conversation needs to be happening. Most people in the United States, in fact, I think it's only about 30% of people in the United States hear about climate change, at least occasionally, which is once every 2 weeks in the media. And so obviously they don't listen to VPR, NPR, because I hear it every single day. But people generally don't hear about it. They don't talk about it. And if they're not even talking about it, then we're not going to get the climate scientists talking to the economists, talking to the business leaders. And we all need to be talking to each other, because we as climate scientists can't be experts in all of these areas. And the only way that we can become experts in those areas is if we're talking to each other.
Couldn't agree more. And the other piece too is always sort of meeting people where they are. And so for me, people always ask me, how do I talk to various audiences? And so, it's exactly what Janel said. You find out who your audience is so that you can bring the information, the data, the stories that are critically important to them. And then there's always that awareness piece, that education piece, so that it's a co-production of knowledge as opposed to a telling, because when you invite folks into a conversation, then you can actually have a dialogue and you can hear concerns and you can listen to questions and try to answer them if you're able to. And so that dialogue piece, that deep listening piece is critically important to anything that we do as scientists.
And like you were getting at there, it kind of goes both ways. We know more about how different people and different stakeholders might be impacted by climate change, but they also learn that too, and they get to start to realize on a local scale how it might affect them or their livelihood or whatever the case may be.
Exactly.
With climate change comes a lot of things that are likely not good, and likely not good for various different constituencies, but there's also a lot of opportunity. There are opportunities in climate mitigation, in different ways of thinking about how to get our power, how to do things like water a golf course, all kinds of areas for economic opportunity, but there also may be upsides to climate change, even here in Vermont. And John Bongartz gets into this in the Q&A. He says, you correctly note many adverse effects of climate change, but there are positive effects as well, like a longer growing season. Vermont will become like Massachusetts. What's so bad about Massachusetts? And, I don't think we need to debate whether we like or dislike Massachusetts tonight, but, there are really things that people enjoy, different kinds of crops that they can grow now. I don't remember peaches growing when I was a kid, and now you can grow peaches in Vermont, and a longer growing season, means those hardiness zones are moving northward a little bit. And so, we have the ability to do things that we didn't before. Ryan, where do you see opportunities and the sort of the upside, at least temporarily, of a changing climate here in Vermont?
Yeah, it's hard to argue with a longer growing season, right? Especially with how long winters are. And maybe the other panelists can speak more to this, but I always wonder what it means in a larger scale. If we get beyond the local scale with our increased growing season, and if we think about food production elsewhere, that might be having negative effects. I'm coming from the Mid-Atlantic, where cranberry production soon isn't going to be economically viable because of climate change. So that's a shift. I think of other regions that might be becoming more arid that are currently producing a lot of food. So I can't speak, definitively on the larger scale, but I think it works both ways. You have, I don't really like to use this term either, but winners and losers, for example. So the other panelists may know more on that.
Yeah, one of the aspects about the growing season, it's temperature is one thing, but you can have warm temperatures, but if you're not getting the moisture, then your plants are not going to grow, right? So when you think about growing season changes overall, the temperatures, the moisture, the types of soils that you're on, but also the
Oh, I think we lost you, Lesley-Ann. Hang on a moment. We're not hearing you. Your audio went out. I'm going to throw this to Janel, and then when we come back, I think it's probably just an internet glitch. So we'll come back to you on that. But Janel, yes, go pick it up from there.
Sure. So I guess I have two responses to the specific question about Massachusetts. I've been there a few times. I don't think there's anything wrong with it. But there's a huge difference between packing up your bags and going to visit or moving to Massachusetts and moving the entire state of Vermont to Massachusetts. As Ryan had pointed out, we have all sorts of species that are adapted to this climate. And, moving the state of Vermont to the climate of Massachusetts in a period of decades is extremely rapid from an ecological standpoint, from a climate standpoint. And it becomes very, very difficult for things to adapt to that. So that's number one. Number two, I would say that this transition to this new climate, it's not like it's a nice, easy transition where every day is going to be, a degree warmer than it was in the past or something like that. Our climate system now, and actually every single day, has more energy in it than it did the day before because of human-caused greenhouse gases. And this energy not just increases temperatures, it also decreases temperatures in some areas. It creates more extreme storms. It changes the way storms travel. It changes the way precipitation falls. And so what happens is we end up with this climate system that's very different to the one that all humans have adapted. And so it becomes more unpredictable. And so that's part of the job that I do with climate models, is trying to get a handle on what this future climate system is going to look like. Is it going to be warmer? Yeah. Are we going to have more extreme precipitation? Yeah. But there's a lot of things that we don't know. And in fact, studies now are pointing to even our forecasts, our short-term forecasts, are actually going to start to lose skill. So you might think that's kind of counterintuitive because our computers are getting faster, our understanding of the physics is improving. But the thing is that we're in this new climate system, which is different than the one to which we've trained our computer models. And so there's a lot of downsides, most of which we actually don't even have a good handle on yet.
Lesley-Ann, I want to come back to you. I hope we have you.
Let's check and see.
Yes, you're there.
Okay. Oh, goodness. So where did I cut out?
Oh, you said about a sentence.
Oh no! Now I have to recapture what I was actually thinking. So I was trying to bring up the point of when you change your growing season and you change the temperatures, you also have to think about the moisture characteristics and think about the pests that might be exacerbated. And there are a lot of these observations, at least from a remotely sensed perspective, where they're looking at changes in the potential, like close to the Arctic, and it's actually going down, even though the temperatures are going up, because again, they're not getting the moisture because the soils are too thin. And so we need to think about everything when we look at vegetation health and vegetation growth to see if we can actually sort of take advantage of the fact that the growing seasons are actually getting longer.
I want to pick up on what Janel Hanrahan was just talking about with modeling, but Lesley-Ann, I want to keep with you for a moment because, I think we can talk more about modeling and how it's done and what the value is. But there are different models, and you can even plug numbers in. Sometimes you can, as a layperson, you can go to a modeling website and say, if temperature changes by this, what am I going to see here? But there are also models that the state is using, and the state is trying to use them to figure out policy areas, but so are people who are trying to think about this economically, and where is the area for entrepreneurship and what kind of business ventures might somebody want to go in. And so there are a lot of reasons why people are reliant on modeling to try to give them some sense of what might be coming. But there's so much variability in the modeling as well. I'm curious, in your job as the state climatologist, how, when you go to state officials or when you go to business groups to say, this is what we think is coming, how you couch it in that variability while still giving people enough information so they can start to make decisions and policy.
So answering that question today on the 5th of May is different than if you had asked me last May, 2020, because sitting on the Climate Council gives me a different positionality, a different intersectionality. And it sort of allows me to get under the hood and actually ask those questions. Are we asking the right questions, and are we using the best models? And that's where we are right now in the whole process. And so I don't have a definitive answer, because that's the question that we're asking in our subcommittees, literally, for the last couple of weeks, getting those models correct, getting those data correct so that we can answer that question, but also getting the stakeholders to the table so that we're responsive to their needs and also responsive to the needs of the state in terms of meeting the reduction in greenhouse gas emission goals.
Janel, how do you think people should think about modeling? You know, we've on Vermont Edition in the past looked at some of the state's models for climate change, and you know there are a couple different possibilities and a couple of different trajectories. And people now may be very familiar with what we see in modeling from COVID statistics, that we get a modeling report every Tuesday, and sometimes we'll hear DFR Commissioner Mike Pieciak saying, you know, here's what the CDC model predicts, and here's what the model that the state uses predicts. But also, it's really dependent on what people do, which of these two curves we're more likely to follow. And so I think people are gaining some familiarity with how modeling works. But I'm curious how you would advise, you know, those of us looking at climate models to think about that variability, to think about the different possibilities, and to think about how our own actions might change the models, or might change what happens, not necessarily change the models, but change what happens and what trajectory we go on.
Yeah, so climate models are used really for two primary purposes kind of in the world of climate change. Number one is the one that you spoke to. It's this idea of projections, right? What's going to happen next? Models are amazing. We can use them to tell the future. I like to think of them as like a time machine. And then the other primary way that they're used is what we call attribution studies, or trying to understand what caused the other thing to happen. So first of all, with the projection piece that you're talking about, I think it's great that you had mentioned that, you know, it's really what humans will do, because it's the same thing with our climate system. There's absolutely some variability from one model to the next in terms of what the global temperature is going to be in the year 2100, right? No two models are going to agree on that. But the spread of all of those different models, and we literally run hundreds of different model simulations and do these projections. And the spread, the disagreement essentially between those models is far, far smaller than the spread that you get if you're looking at humans adding more carbon dioxide to the atmosphere and humans stopping putting carbon dioxide in the atmosphere and then taking it out. And so the biggest uncertainty when it comes to climate change projections is not limitations with respect to our understanding of the climate system or modeling limitations. It's what humans will do. That is the biggest unknown. And so it's really important to understand that. And I just want to mention briefly this idea of attribution, because and I should say attribution, but also this idea of model optimization, which was a little bit more of what Lesley-Ann was talking about, is trying to make sure we're using the right models for the right regions. You know, models are amazing because they're different. They're like alternate universes. So we can tweak little things and play it forward and see what happens. And it's really interesting. So for example, some work that I've been doing, we've been warming up and cooling down the Great Lakes. And we can do this in the model. And then we're taking a look at how that impacts precipitation in our region. Why might we want to do that? Well, first of all, we want to see, because the Great Lakes are warming up much faster than the surrounding area, is that part of the reason why we're seeing more rain in our area? Number one, but also we need to know how important is it that we're getting the lake temperatures right in our models, right? Because that could have an impact. So this sort of thing is happening all the time. But generally speaking, when it comes to understanding these climate change projections, like the really long-term climate change projections, when it comes to something like global temperature, the biggest unknown is what people will do.
Ryan, Alice would love for you to touch on the increase in non-native invasive plants and insects as the climate changes. What can you tell us about what you're seeing?
Yeah, so the changing climate can certainly open the door for many more non-natives or, you know, invasives of both insects and plants than otherwise. Again, it kind of comes back to this general concept of competition. And a species that has a tendency to become invasive in a new area is one that becomes a really good competitor and that cannot compete most anything in the area, likely because it hasn't evolved and doesn't have any real limiting factors. Certainly a more mild winter is going to make more of those, potential competitive interactions beneficial for invasives. So, that's not necessarily the reason why an invasive takes hold in the area. It has to depend on how they're spreading or how they're introduced, but it can certainly create conditions where more of them that are currently limited to more southern states can in the future establish up here as well.
We got a note from Jennifer of Westfield, Indiana, who says, in light of climate change, water security, drought, etc., where's the best region of Vermont to live? Now, I can see all three of you sort of, uh-oh, how do we do that? But, I think this is a question that gets us to that question of climate migration, of how Vermont can prepare for the possibility of people wanting to come here because of what you were talking about earlier, with at least a short-term potentially beneficial change for the state, and because people are going to move from places where the climate is less hospitable into places where the climate is more hospitable. And so we are likely going to face some of this. And again, we're going to be dealing with a situation where some people have agency and resources and can buy the $700,000 house, and some people can't, and perhaps can't get out of a bad situation. So, Lesley-Ann, I know this is a huge question, but how do we approach that? And how do we even approach a question like Jennifer's about where should I live in Vermont?
So that's a hard question, because it comes down to affecting people's lives, and you want to be able to provide the best and the most accurate and most comprehensive information that you can. But then thinking about the realities of the state, two things I probably want to point out. The first is capacity, and capacity of receiving towns, cities, municipalities, hamlets. That's one piece that I don't think we've addressed yet as a state, because the topic is so new. And the other piece is the physical geography of the state. And so when you move into any part of the state, are you moving into a more urban area, a suburban area, an exurban area? Are you moving into an area that is more rural? Where are your water supplies coming from? And are you going to be on town water? Are you going to be on a well? How deep does that well have to go? And because we're starting to hear a lot of stories of folks who have been on wells for 4 decades, 5 decades, or have 3 generations, and the wells are now starting to run dry. And so it's a non-trivial question, actually, because there are just so many moving pieces. And so I think if I were in the position of moving in, there are aspects of the soils, the geology, the groundwater supplies, where your storm systems are. What Janel did, looking at where on the landscape do you actually, I did that myself when I moved to the state. I made sure that I was like the highest part in the neighborhood and not the lowest part, because it tended to flood. So all of those pieces are non-trivial in terms of the capital outlay that would be involved, in terms of access to school systems and everything else. And so there are all of these decisions that have to be made as a family, whether it's in financial, whether it is in cultural, whether it's in, all of the things that make us whole as communities, as people. And so I think those are some of the pieces I always think about, because it's challenging.
Janel, is this somewhat related to the work that you were doing in Canada, thinking about how a municipality might change its systems based on what's going to happen with water and with resources, but thinking about even at the sort of, I live on a well. I'm worried about this for my own house because we don't have any municipal water supply. But for cities and towns in Vermont that do, this is going to be a consideration for them as well. Can you talk about the work that you did?
Sure. So at the time in central Alberta, and I haven't really been keeping tabs on this since I left, but I know that flooding has continued to be an issue there. But the flooding in Edmonton and Calgary, which is just south of there, was just happening year after year after year. And it was flooding that was inundating, the downtown areas. So it's pretty catastrophic. And when I got up there, what I found out is that the precipitation data that they had been using were already a decade or two old. And if you think about how quickly climate change is modifying our extreme precipitation, it was clearly outdated. And so my job up there was to do climate projection. So that way we essentially have future climate data, because the year that you gather your precipitation data, we're already in a new climate system by the time you get to the new year. And so we can't kind of do what we've done in the past, where we just make this assumption where we have this steady state climate system where we create our hydrologic infrastructure based on the last 10 years, because it's changing so rapidly. And so this is something that cities are going to have to be thinking about, not only in Canada, but in the US and around the world.
Ryan Rebozo, Alan wonders along these lines that we've just been talking about, how can I best prepare my home and family for climate change? I know this isn't your area of expertise, but you must think about it as you think about all kinds of systems changes and ecological changes. How do we think about those ecological changes on the human and family level?
Yeah, absolutely. I think what we were just hearing in terms of some of the things to keep in mind, particularly hydrological, is really good in terms, for planning to the best, of our abilities, whether it's the well or avoiding areas that might be prone to flooding, for example, and more extreme events. I think when you kind of extend the question to the greater ecological concept, it adds a level of complexity, because our interest in that is ecosystem services we get. And, we, I think, have a hard time trying to wrap our minds around that. What exactly are we getting from natural systems? We can name some of them, air quality, the water filtration, and, pollination services, for example. But in order to really maximize that, I think we have to think about prioritizing large blocks of functional habitat and large, meaningful corridors. So as things need to move and disperse as well as they can, individuals of populations can do that. Genetic materials can be exchanged. But it is a difficult thing to add to an already complex question of climate change, right? We have climate change as complex as it is. Then we have to consider biodiversity, and then what biodiversity means for all these ecosystem services that we really have a hard time with defining. So it's just different levels of complexity, but all really worthwhile and to think about and consider when we want to talk about planning for the future.
Do you think we need to think more carefully? Sorry, Lesley-Ann, I'll come back to you. But do you think we need to think more carefully then about, and we've started to do this in Vermont communities, but as we think about habitat fragmentation, really concentrating on policies that will invite people to live in more concentrated areas in downtowns, which will require some systems changes, which will certainly require broadband infrastructure and other things, but will also require a real change in mindset for so many Vermonters who value living really rurally, which often means where you don't see any other neighbors, and that's not going to be possible if what we're trying to do, and with the potential of more people coming in, is to make sure that we're preserving large tracts of habitat.
Yeah, absolutely. I mean, it can go one of two ways. I mean, one is just, density. We consider what density looks like in even these more remote areas, or concentrating more people into small areas of higher density. But certainly, I mean, Janel mentioned what we were talking about. What are some maybe short-term benefits? I think, other than, being able to grow certain things in your backyard, I'd get away from that just because of how quickly, the climate is changing, and we're not really sure what that's going to do to our biodiversity. And really, that's the idea behind protecting these large blocks of land, having high levels of biodiversity, because when our systems are more diverse, they're more robust to changes, right? Changes in climate, stochastic changes, right? These seemingly random events. More niches get to be filled, and they get to function and provide these ecosystem services that we really depend on. I mean, again, I mentioned this already, but we often don't think of it day to day, but we really are tied to these natural systems. And the more robust and diverse they are, the better we are for it.
I want to let those of you who are watching tonight know we'll probably talk for another 10 or 15 minutes or so. So if you do have a question, go ahead and throw it in the Q&A section. I've seen a couple of you, it looks like you're raising your hands, but we can't invite you to join the panelists tonight. So if you do have a question, throw it in the Q&A area. Comments, welcome to, I can push those comments in so that everybody can see them, or you can add those to the chat. But Lesley-Ann, I think you wanted to make a comment as well.
Yeah, I just wanted to piggyback on what Ryan was just talking about and the go back to something that you had mentioned earlier when we were looking at the need to have everybody at the table, and that includes both private and public landowners, because so much of Vermont is in private land ownership, and so making sure that we have all the key players at the table as we have some of these really hard discussions, and thinking about nature-based solutions, thinking about our working lands, thinking about the way in which we use every aspect, every like square inch of the state, critically important, so that we do have that sort of collective way of looking at mitigation and adaptation.
We had a question in the Q&A area from an attendee who says, what can we do to help our climate? What is Vermont doing other than the composting bill? So the composting bill is one. We certainly have our climate strategy and climate goals, but what is the state doing? Let's talk about it from a state policy level, and then we can branch out into individual levels and broader into what needs to be global climate policy, which includes things like the U.S. re-entering the Paris Climate Agreement. But Lesley-Ann, maybe you're well positioned to talk about what the state is doing.
So at the state level, December 1st is our deadline for getting the climate action plan together. And the way that we're envisioning it right now, as we sort of play things out, is to try and meet the targets of having the greenhouse gas reductions, the recommendations for that in place, with the realization that that is probably the first step in our mitigation strategies, and then trying to line up what the rest of those might look like for 2030, 2050, moving on out. So that's one track, but also at the same time, what are we thinking about from an adaptation perspective, and what are some of those, again, going back to this sort of nature-based types of solutions, the things that we can think about because we're such an agriculturally based state. What are some of those other pieces that we can look at, for example, thinking about fermentation on agricultural lands, all of those pieces that we can bring to bear to make sure carbon sequestration and all of those pieces are part of the things that we are putting forward as a state. So those are some of the things that I know we are actively working towards, and just sort of setting up the timelines and how quickly we'll be able to achieve those.
It's so interesting, though, because, as we think about all the things that we've been talking about this evening, there is so much policy and culture that touches on climate change, but isn't necessarily sort of tagged climate change. Even things that we think about, like the infrastructure of our downtowns, is going to have an impact on our settlement structure, and that's going to have an impact on our ecosystem and could have an impact on climate. And so much of what we do is really woven into what is happening and what we are doing to the global climate. It's just interesting to think about how many policies we may need to be thinking about from that climate lens and from that equity lens and from all these other lenses, not just broadband infrastructure or
Right.
well waters. It's daunting, is it not, Lesley-Ann?
I think that's an important piece because sorry, but you're right, and I think that comes to how scientists have to start communicating their work and these issues to policymakers. We can have these kind of instrumental knowledge exchange where a paper or a study may influence a decision or a bill a policymaker is involved in, but more likely than not, it's going to be this kind of what we call conceptual knowledge exchange, where in communications with people on the science field, we bring a topic like climate change up to the forefront of a policymaker's thinking. So when they see a bill that isn't tagged climate change, and it might be infrastructure, they're already thinking of it through a climate change lens. And that's more often than not how these kind of communications become more productive. So that's
right. Interdisciplinarity, absolutely.
Janel, what about on the personal level? We know that this is not a situation that can be fixed by each of us making small individual changes, but are there small individual changes that actually move the needle? Whether it's changing our own behaviors or pushing for things at the state and national level that need to be done, because those are also individual behaviors that could have an impact.
Yeah, I think climate change is to the point now where the individual behaviors are still important, but I think they're becoming less and less relevant. And I hate to put it that way. And I think a good analogy is that if your house is on fire, you can be grabbing cups of water and dumping it on the flames, but really nothing's going to happen until the fire department comes to put it out. But the thing is you got to know that your house is on fire. In fact, you have to believe that your house is on fire before you call the fire department. And so we're at a point right now, even today, that if you ask kind of the average American, do you think humans are changing our climate system? Only about half of Americans, US adults, think that that's the case. That is a problem. That is a huge problem. Because if we don't understand our role in this problem, then we're never going to be able to fix it. And I like to tell my students that the best part about climate change is that we are the problem, because that means that we can fix it. We just need to make a decision that we're going to do it. And so, while I do think that, if you can get an electric car, great, but it's expensive. That's hard to do. If you can get solar panels, great, that's expensive. That's hard to do. Those are huge hurdles. And for somebody who's just trying to figure out how they're going to pay next month's bills, they're not going to be thinking about those things. So those things need to be made much easier than they already are. So I think that really what people need to be doing is they need to be talking about it. So similar to what I said previously, that people don't hear about climate change in the media, they're also just not talking about it, even with friends and family. And so, especially the young people who might be tuning into this right now, I know oftentimes I talk to middle schoolers and high schoolers, and they're learning about the science and they're scared to death, yet they can't even go home and talk to their parents about it because their parents don't believe it's happening. And think about how ironic that is, right? Because when I teach climate change to my students, we're talking about thermodynamics, atmospheric dynamics, it's math, it's calculus. That's what we're teaching them. I'm not standing up there talking about my opinion. And yet, when they get home, their parents don't sit down over dinner and argue with them over, algebra, right? But yet, as soon as it becomes climate change, it becomes politicized and it becomes very divisive. And all of a sudden, everybody has an opinion. And that part needs to stop. We need to put the science back into climate change. I realize that the political piece in my mind is what we do about it. That is absolutely politics. I totally get that. And that's outside of my expertise. But when it comes to actual climate change science, what has been happening, what's happening now, and what we think is going to happen into the future, that's science. And we need to start minimally by understanding or at least believing in the science before we can get to the next step, which is political.
But how do you do that? I mean, you and other scientists have been saying that for years.
Yeah.
So it's not that you're not saying this is science, this is fact, this is what we know, and this is how we know it, and these are how we use models and how we make models. I mean, if you're doing that, is it that scientists are not doing that kind of outreach with the public, or is it that the public is not getting the message in certain ways because of the media they consume? Whose job is it to fix that narrative then?
Yeah, I think it's ours. I think it's ours as scientists, not because I want it to be our job, not because I think we're the best at it, but because I don't know at this point who else is going to do it. I was really struck when I entered the field of climatology 15 years ago at these two parallel worlds that are in existence. You go to a conference, scientists are talking about not whether or not climate change is happening or not whether or not humans are the cause, but all of these little details about, what's going to happen in northern Vermont versus southern Vermont or something like that. But then you talk to a politician or someone just on the street, and they're still grappling with this fundamental idea of whether or not it's even happening. And so we need to figure out a way to bridge those communities. And I really think a lot of it is just ingrained in the way that we as scientists are trained. As we get our degrees, as we go into academia, if you land a tenure track position, everything is based on how much you publish in the peer-reviewed literature. It's read by other scientists. How much you present at conferences, which are only attended by scientists. And so what's been happening is we have this culture where we're trained to talk to each other. And quite frankly, many of us don't want to talk to the general public because it's really, really, really hard to do. And so what we're doing here at Northern Vermont University is we're just trying to provide opportunities for our students to start engaging with the public. And we're trying to instill this sense of responsibility to engage with the public. And we're trying to put some reward system in place, like in the form of scholarships. We've had some local donors for that. And so we're in fact, right now, we're also partnering up with some other institutions. We have 8 universities involved right now. We're trying to expand the climate consensus nationally so that we can start doing this sort of thing kind of from the inside out. So there is a lot that's being done, I think. It's just, it takes time, I think, to overturn this culture that's been so ingrained in us.
And just to piggyback on that, state climatologists are actually in a really good position to be that bridge because they have a mandate from the national organization to be that local boots on the ground type of outreach and provide outreach communication service and research to all of the people within their state. And so a lot of state climatologists are either applied climatologists or service climatologists, and that's what they're trained to do. And then recently there's a group called SciLine at the American Association for the Advancement of Science, which works directly with reporters. And what they do is try and get ahead of the curve in science that's coming down the pike so that they can write these briefs, whether it's a COVID brief or whether it's a climate change brief, so that it's all set to go so that when a reporter has to do a story, they actually have the stuff that they can put directly into the story, put it on air, put it into wherever it is, print, news, media, so that they don't have to sort of go find that expert. And it sort of reduces that hurdle, reduces that barrier. And so there are a couple of these things that we can sort of maybe amplify that are in place right now to be that bridge in the gap to help between the scientific community and getting that knowledge out, because it really becomes a co-production of knowledge.
I think it's I think the conversations are moving in the right direction, but there's still, some ground to make up. And I think the points that, the two of you are making were right on. It's not a belief system, right? So we kind of maybe should get away from talking about it that way. You can certainly disagree on lots of things. You can disagree with the way a study was done or the conclusions authors came to, or disagree with the methods used to address climate change. But the more people that realize there's a scientific process behind this, and the more science literacy improves, people will understand what the confidence is and what that means, or the methods used to come to some of these opinions or conclusions rather. I think we're moving in the right direction, but there's certainly some way to go.
Yeah, I will say, of course, it's not all the scientists' responsibility, and certainly the media has played a huge role in this over the years. And more scientific literacy within the media is crucial as well. And something that we've been grappling with in our news departments around the country for years now, but it applies to climate science as well, is how do you offer truth without opinion, which may be different from neutrality, which may be different from just purely, it is still objective, but how do you make sure that you're not doing sort of both sidesism? And we decided on Vermont Edition, I think probably 10 or 12 years ago, to make a really distinctive point of saying, we are not going to have debates about whether climate change is real. The policy debates are more interesting anyway, but we are not debating climate science. We are going to debate policy, and we're going to talk about climate science. And at the time, that felt a little bit scary. It felt like we were a little bit out on the edge. But as we think about the value of science, that question of how do you make sure that when you're talking about science, it's not opinion. It's not, as you said, Ryan, something where you talk about faith or a belief. It is based on what is known and what is, hypothesized even before it's known, that you're not talking about opinion as if science and opinion are the same thing. And that's been a challenge for the news media, certainly. But so I don't want to leave my own occupation off the hook here as we think about how climate science is conveyed to the public, because the media is often that part of the puzzle, the part that's right there, that all of that information goes through.
Hey, Jane, I just want to mention something really briefly about our broadcast meteorologists. There's an amazing program out there. It's called Climate Matters right now, where they're hiring climate scientists to put together these graphics and kind of storylines so that broadcast meteorologists can start to talk more knowledgeably about the science of climate change. So that is another way that I think we're starting to get some of the science into kind of the American household.
Yeah, it is all interesting to think about, how this is going to move forward in the next few years. Let me just get a few more questions in because we still have a lot of participants and a lot of people asking questions. So we'll just try to squeeze a few more in here and end by 8:30 for those of you who need to get on with your evenings. Walter Norman says, do the models predict a uniform percentage increase in precipitation across Vermont so that spreads between the drier areas of Vermont, like the Champlain Valley, and wetter areas like the Green Mountains will increase? Or are the models forecasting a change in the type and distribution of precipitation, which will affect the climatology of Vermont? And drier areas could become wetter, while some currently wetter areas don't experience as much of an increase. Which one of you wants to tackle? It's a lot. It's a lot to tackle. But, I think the question here is, how do we figure out whether there's a uniform change across the state or whether it's really variable based on topography and location and other factors?
I can briefly tackle that and say that I would say the science isn't really to that point where we can say that this part of Vermont is going to do this and this part of Vermont is going to do that. It depends on the season. It depends on whether you're talking about upslopes or downslopes and whether the direction of the upslope is going to change with the jet stream. And so there's a lot of variability, I think, in what the models are telling us. So generally speaking, we know that extreme precipitation is going to increase probably across the state. But there could absolutely be some regions where that's not the case or we have more drought than other areas.
And that's already the current case where the southeast part of the state is the drier part of the state and the northeast kingdom is the colder part of the state. And so those spatial variability is not going to change. And then on top of that, when you layer in how the temperatures and the precip are going to change, that might either magnify or just sort of continue to be with those spatial changes that you're seeing.
We got a note from Betty and Ron who say, you need to seriously consider population control, as population will outstrip any climate efforts we make. It's been interesting to look at newly emerging census data, and Vermont was perhaps a little surprised by the increase in our population over the last few years, 10 years, but also over the last few years. And, when we think about that, that's a little bit of a positive note in many ways that it's talked about here in Vermont, like, oh, this is good. We've got more people. And when we think about US population growth, it's often been talked about so far as not enough growth. This is a bad thing. Our population is not growing enough. And we hear that said in Vermont as well. And Ryan, I'd love for you to jump in as we think about this, because do we need to change our idea, our economic models, our sense of whether population growth is the key to economic success? Do we need to, as Betty and Ron are saying, think seriously about population control and reframe economic success and models?
Yeah, I think you do have to seriously consider populations, because as populations increase, there's less and less we can get away with if we don't have good land use planning, right? It makes our land use planning that much more important when we consider, the resource needs of new people and communities, whether it's water resource, whatever the case may be. So, you can get away with maybe less than ideal rules and regulations regarding how we manage our natural resources when you have a much smaller population. And it gets a lot harder to get away with those types of things as those populations increase.
We got a question from Anna Rubin, who's with the Fairbanks Museum, who wants to know, what do you consider essential climate literacy fundamentals and how do we continue to stay informed? So let's take the last few minutes here to talk about, where we go from here, what people can do to learn more, to get better informed and to better inform others. Lesley-Ann, I saw you unmute yourself immediately.
That's because there's actually something called the essential climate literacy principles. I helped work on that about 10, 15 years ago, and I'd be happy to send a link to the person who asked the question. I think part of it comes down to understanding all of the things that go into weather, that go into climate, but then using that knowledge and understanding to make informed decisions. So there's a sort of responsibility piece in there, but you can't make a decision if you don't have the knowledge. And if you don't have the knowledge, then it comes back to that access issue and the awareness issue and the education issue. So it's incumbent on us as scientists to help share that knowledge, but share it in a way that can be received and understood and appreciated, so that as folks hear it and they can use it to make their life decisions, because that's the end goal in climate literacy.
I mean, the state has a pretty great website. I was looking at it just in preparation for this, in terms of what is happening with climate change right now and what the projections are. The state of Vermont, Climate Change in Vermont, an official state website that was, I found, really informative and written in a way that is easily accessible to everybody. Is that one resource you think more people should be checking out, Lesley-Ann?
Definitely. And if they would like a little bit more on climate change, there's a National Climate Assessment website, which delves really deeply into whether you want to do multiple stressors like COVID and climate change, for example, or international impacts. Like we live on an international border. What does that mean for us in terms of climate change? What does it mean for us in terms of being a Northeast resident? So National Climate Change is another great website.
Janel, Hanrahan, what do you think about for making sure that we are climate literate and that we are helping others to enhance their climate literacy?
So maybe I'll turn that around a little bit and say one way that you can help to make sure accurate information is getting out there is by helping to support scientists who are willing to talk about it. Because, if you have an upcoming atmospheric scientist and they have one negative exchange with somebody who, starts trolling them or starts really challenging them on the science, they may never engage in that type of conversation ever again throughout the rest of their career. And so just giving especially upcoming scientists and even seasoned scientists, because a lot of us aren't terribly comfortable engaging with the public either. And so, just giving us a pat on the back or thanking, especially if it's a student, for speaking about the science and asking questions, I think is really, really important just to ensure that that sort of conversation continues to happen moving forward.
Ryan, before I go to you, one other question for you there, Janelle, on this. How are scientists reaching out to people who don't have access to technology that might provide venues like this Zoom panel discussion available to them?
Right now during COVID, not a whole lot. But normally my students have been getting into middle schools, high schools. It's been a really great venue for them to start practicing talking about the science. And then also just saying that we'll be kind of a scientist in the room if needed for sometimes even hard things like policy discussions or decisions, but not to discuss the kind of ins and outs of the policy, but just to represent the science itself.
Ryan, what about you? Where should people go from here? If they're energized by this conversation and want to either do more or learn more, what's the next step?
Yeah, there's lots of resources that we just heard about, but also contributing to organizations that can use help, whether it's just the citizen science work we were talking about, and it could be on the biodiversity side or collecting climate data. That's a great hands-on way to contribute something useful and to get more involved, engaged, and learn more about the issue. I think I would recommend that for anybody who's interested.
Don't forget our science museums.
Right.
Yeah.
Yep.
Absolutely. And speaking of places that need support coming out of COVID, absolutely. Well, let's leave it there because I think there's a lot for all of us who have been listening to the three of you tonight to digest and think about, and then maybe decide where our next action steps are or future research is. So I want to thank our panelists this evening, UVM climatology professor and Vermont State climatologist Lesley-Ann Dupigny-Giroux, Director of Conservation Science at the Vermont Center for Ecostudies, Ryan Rebozo, and Associate Professor and Chair of Atmospheric Sciences at Northern Vermont University, Lyndon Janel Hanrahan. Thank you all three. What a wonderful way to be able to think and talk about these subjects tonight. Thank you for participating.
Thank you.
Thank you.
Yeah, thank you.
Have a good night, everybody.
And for everybody who's watching tonight, there will be a recording of this conversation posted in the next few days for you to watch again or share with others. You can find it at their Fairbanks Museum website, which is fairbanksmuseum.org. And while you're there, you can learn more about a tree planting event at the museum and ways to participate in the museum's ongoing efforts to get involved in the climate conversation or to become a member, as Adam talked about earlier in the evening. Thank you all for being here tonight. Have a wonderful evening and good night.